Hi there, this is Shrikant Dasari. So in this lesson, we are going to learn how to build a circular queue data structure using an array. Okay. So before starting off with the actual building process, so here I decided to build the program from the very scratch. Okay. So rather than taking a code, a sample, and explaining you through walkthrough, so better than that, if you build from scratch, it would be more easier to understand. Okay. So first let us take the very basic things which are going to be our header files. Okay. So since we are building this data structure in C, the most essential header files are going to be hash include std.h and hash include conio.h. Okay. So next we need to take so whatever the required variables like array and elements like front, rear, and data, all those things. Okay. So here our intention to keep the program as simple as possible. So here I am making everything as global data. Okay. So global declaration. Okay. So first and foremost is going to be our macro. So has defined a max of 5. So here I am building a circular queue of 5 elements. Okay. So before going deep into the program, so first let me say a few words about so what is a circular queue. Okay, so in normal queues, so if you go back to our if you revise the queue data structure, in normal queue there is a problem, which is that so if we already have some elements deleted from the front, and if we have at least one element in the rear part, and the remaining empty, even though we have empty spaces in the beginning, our in the normal queue data structure, which is based on first in first out, it would not allow us to enter the elements. Okay, even though there is a room for it. Okay, the circular queue the circular queue has an advantage of it checks, it only shows full if all the elements in the queue are filled up. Okay, so even though you have empty spaces in the beginning, for example, if you have all the elements got deleted and you have one element or at least one room after the rear position, which is the beginning or the starting slot, so there you can insert an element. It checks in that way. Okay, so as we said earlier that we are going to build the program using a queue, sorry, array. So first our array declaration is going to be like this. I wanted to name the array as CQ of, let me put it as the macro, with the macro here, which is going to be the max. Okay. So next, other important variables needed to be declared as globally are front and rear. Okay, the front and rear. As we know that if you are familiar with queue data structure, the front always keep the elements in the queue are going to be deleted from front. Okay, so whenever the element you need to delete from the position of the front, and if you want to add an element in the queue, you need to add from the position of the rear. Okay, so to maintain that status we need both front and rear variables. Okay, last but not the least, in another global variable declaration, which is going to be data. Okay, so here data is actual element which is going to be inserted inside the circular queue. Okay, so like 10 or 20 if it's a case of integers. So you can take characters also, so if you are building a character circular queue or something like that. Okay, so next let us build straight away, right, the main function or the structure of our so what we call the menu structure. Okay, so the queue, like queue, circular queue also has certain operations like add an element in the queue, delete an element, display the elements, and exit to come out of the execution. Okay, so first let us do that. And before that we need to the first and foremost thing, we need to initialize our front and rear to -1. Okay, so this is because the initial condition to test whether the queue is full or empty is going to be through -1. Okay, so if initially the value which must be placed inside those variables is -1. Okay, so if you want to add an element, then you need to increment the rear, and then you need to add an element in that rear position. Okay, so if there is at least one element in the queue, then the front also will be pointing to 0 only. Okay, So next, let's write the printf statement here. It's very familiar. The first one, add. Okay. So before that, forget to tell one more thing here. So we need to take ch choice, and all this stuff must be inside a do loop here. Okay, so do while loop, because so we need to iterate. So again and again we need this menu structure here. Okay, this is very familiar thing we are going, which we have done in all other previous lessons also. So to delete, it's going to be delete, and 3 slash and slash t. 3 is going to be a display of all the elements in the settler queue. Excuse me. Okay, so the fourth one is going to be the option or choice to exit out of the execution here. Okay, so here we have all the different menu choice options here, and then we need to ultimately ask the choice, enter the choice, or something like this. All these things are very basic and elementary level things, so don't get bored before I develop this kind of menu. So I could have done this previously also, but as we said in the beginning, I wanted to build the whole program from the very scratch here. Okay, so here we have done with our menu, and let's keep a switch here. Okay, so switch of ch. Okay, switch of ch. So let me put all the cases, so which we are doing from the very beginning. Let me put a break. Let me put a break here, and case 2. Case 2 is going to be another break. Nothing happens. Nothing excited happens here. And case 3 is going to be another break. Okay. Okay. So nothing happens here. Nothing excited happens here. So let us write the while also. So let us write the while thing, while ch not equal to 4. Okay, so here we are going to loop until the option which is not going to be 4 here. Okay, so if everything goes fine, let me run until this instance here. Okay, so here we have a wonderful menu. Okay, so we have a beautiful menu here. So let me take the option 1, nothing happens. Option 2, nothing happens. Option 3, nothing happens. And option 4 should get us out of the execution. Okay, so nothing much excited has happened here. So because we need to write the actual and real code starting from now. Okay, so our intention is to perform all the operations. So add operation, the delete operation, the display is quite easier. Okay, and the exit is nothing. If you give 4, you get out of the execution here. Okay, so first and foremost, so I'm just titling. So in order to not to write the prototypes or define the functions after the main function, and write the prototypes in the beginning. So to avoiding all those complexity, or make just to reduce the lines of code, I'm just directly defining the methods out of the main function here, about the main function. So void add, so void add, so void del, so void del, so void display, so void display, so void display. Okay, so I just put some blank definitions for everything. So we need to write the code inside here. Okay, so nothing happens. We need to write code. We are going to write code for the actual function. So add is the function which deals to add some elements into the queue or circular queue, and delete is going to delete the elements from the circular queue, and display is going to just show the elements in the circular queue. So if you want, you can call those methods here. Nothing happens because we haven't yet written the code. Okay, so if you want to display or view the elements of your code. Okay, so everything goes well, nothing happens as usual, nothing happens. So just keep on taking the options here. 4 for exit. Okay, so now, so first and foremost, we need to write the code for adding operations. This is not quite easy as our previous queue data structure, not quite straightforward. So we need to test a lot of options here. So first let me build the code for add, and then we are going to test it by executing the program. Okay, the first and foremost thing is going to be if rear if rear is equal to max minus 1, if rear is equal to max minus 1 and front is equal to 0, or rear plus 1, okay, or rear plus 1 is equal to front, okay. So first condition itself, so don't get panicked with the huge conditions here, okay. So all these things are based on algorithm, so because we need to test each and every condition here. So here this condition says that the queue is full, okay. So here this condition says that the queue is full. So let us put that message here. So printf /n/t, let's say not a, here we are going to build a circular queue, so let's say circular queue is full, okay. Circular queue is full, and let us close the statement, and let's say return one such that the other code does not get executed, and let us put it int here, okay. So this is the first and foremost condition. So why we have so what is our real intention in putting this statement, we will understand when we will execute the program, okay. So if we put the front and rear positions in the printing while executing the program, so we will understand more better, okay. So the next condition is going to be this one. So if rear is equal to max, if rear is equal to max minus 1, okay, if rear is equal to max minus 1, then we need to say that rear is equal to 0, okay. So if rear is equal to max minus 1, rear is equal to 0. If that is not the case, in the else part we need to say that rear plus plus, okay. So if rear is and max minus 1, or if the rear doesn't reach the maximum element, if it does reach, then we need to put we need to make the rear as 0. If that is not the case, in the else part we are saying that rear is equal to rear plus plus, okay. So now the actual entry part of the element is going to be taking place here. So let us say, so printf /n/t, so enter the data item, so let's say close, and let's put a scanf statement here. So in order to grab the input from the keyboard, so we are not using as said earlier that we are not using any arguments or lengthy code, not to make it more complicated, and also to keep as low lines as possible. So scanf and ampersand data, so that's what we have taken here, okay. So if you go back to your global data, so data, the purpose of data here now comes. So here we are just grabbing the data, and what we are going to do is at the position of rear, so here the name of our queue is CQ, okay. CQ of rear is equal to data, okay. CQ of rear is equal to data. And the last condition here, so so we are in a position that, so if this is the first element in the queue, so the element got inserted in the rear position, and now our duty is to make that front also 0, okay. So if at all one element is entered in the queue or circular queue, so here whenever I say queue, kindly take it as circular queue only, okay. So if at least one element is there in the circular queue, then the queue is not empty. So there is no case in point that still making our front as -1 value, front value as -1. So for that purpose, so now we have to say if front is equal to -1, now we need to say front is equal to 0, okay. So this is the last but not least case here, okay. So this is all about the adding an element in the circular queue. So let us run the program. So everything goes well. Something has failed. Somewhere I had an extra s here, like crazy. So here it is, okay. So let's run the program. Equal to left, oh, CQ of rear is equal to data, rear is equal to 0. Somewhere it's showing a mistake here. Let's see. It says in the 9 front is equal to 0, rear plus, oh, did some crazy mistake here also. It's a comparison operator instead of, okay. So everything if everything goes well, if I take the option 1, it asks for us to to enter some data element here. So let's say 1 here. Okay, again if I take the option 1, let's say it asks another data element, so let's add 2. Let me keep on adding the elements. Let us test the queue full condition, circle the queue full condition here. Okay, so I have done with 5 elements, so I haven't written any code for display. So let's try to add one more element here. So it does not allow me to add one more element, because if you check the code, here once again, if the rear part is equal to max minus 1 and front is equal to 0. Okay, so if you go and out, let me come out of the program and let us print it out, the positions of front and rear here. Okay, so for better understanding, let's say front is equal to %t comma front. Okay, so let's say printf /n/t. So rear is equal to %t comma rear. Okay, so now if you can understand the code more better here. Okay, so if I keep on adding the elements, so the first, as soon as I entered the first element, the initially the front and rear, okay, the front and rear are -1 here. Okay, so first so as soon as we have added an element inside the queue, the front and rear now gets as 0. Okay, so first the rear gets 0 value from here, and then if front is still -1, we are making it forcefully as 0. Okay, so that's what we have got in the output here. Okay, so if you keep on adding the elements, so now the front value is 0 and the rear value is also 0, and there is only one element in the queue. Okay, sorry, circular queue. So now if you take another element here, so let's say 2, now the rear gets incremented here. Okay, so from the previous run, if both the values of front and 0 are 0 and 0, so now it's 0 and 1. So if you keep on adding the elements, taking the first option once again, let me say 2. So if you observe, the rear value is 2, so rear gets on incremented here. Again 1, data item 4, the rear gets 4. Again take choice 1, data item, let's say 4 or 5 or something like that. So rear value is 4 and the front value is 0. So we have reached the maximum size of the queue, which is so max is size -1. Okay, so that's what we have got. Since the array index begins from 0, so there is no room for elements. So if you test the condition, so that's the reason we are getting here. If I try to add one more element, it says the circular queue is full. It does not let me add another elements. Okay, so for the reason behind that is that if I say something, if I come back here, so if you test this condition, the very beginning condition, the rear is max -1. So if we go back to our execution part, so the front and rear, since it's not showing here because it has scrolled up a bit. So here if you observe, see, the rear is max -1, which is 4, and the front value is 0. So that's what we have given here, and obviously it says that circular queue is full. Okay, so let us put a system CLS also. So for all the, so this is a Windows a Visual C++ specific function. So if you're coding in other IDEs, you can use the CL or SCR or whatever equivalent to that. Okay, so let us run once again. Okay, let's come out of this and let's run once again. Okay, so coming out of that, it would be nice, everything goes well. The system, oh system CLS, some problem had occurred. Just a second. Oh, just a second. Okay, so here we are. We have just added the system CLS, and we have added the corresponding header file, which is stdlib.h here. Okay, so let me run the program once again. Okay, so let me take the add option. Let me add the element. So since I am adding the first element, it always says that the front and rear are 0. Let me take once again. So if you keep on adding the elements, you keep on getting the front rear part as incrementing here. Okay, so this is up to the add function. So let us we have a lot to do more. So if we try to add one more time, let's say circular queue is full. Okay, so let me get out of this and let me try to write the code for delete function also. Okay, so delete. Okay, the first and foremost thing, let me change the return type to int here. Okay, so int del, that's what we have written. Okay, since we can't use delete as because it's a keyword in C++, since we are using a Visual C++ IDE, it might keep us in some sort of troubles. Okay, so we should not use the reserved words or keywords as names of identifiers. Okay, so if friend is equal to -1, the first and foremost condition you need to check before before trying to delete an element from the circular queue or whatever it might be. So first we are checking this condition because first there should be some at least one element inside the circular queue such that we can perform the delete operations. If there is no case in point of deleting an element from an empty queue. Okay, so this leads us to that underflow condition. Okay, so you're trying to perform delete operation when there are no elements here. Okay, so let's say queue underflow, or let's simply say the circular queue is empty. Okay, circular queue is empty, or underflow error, or whatever it might be, you can say. Okay, so let's say return 1. Okay, circular queue is empty, and let's say return 1. Okay, and now we need to take the data from our element here. Okay, so data from our circular queue out. So since we are taking the element out, which literally means that deleting, so let's say that like this. So C of CQ of front. So we need to be very careful. In the previous function definition, we have used almost rear all the time. So because entering the element is done based on the position of the rear, and the deleting element is always done based on the position of the front. Okay, so that's what we are going to do here. The CQ of front, we are taking out the element from the front position and placing in data, and in that position let us put CQ of front is equal to 0 or something like that. You can put a 0 or to just to show that it's empty. Okay, so and then so if we keep on deleting the elements from the front when the queue is full, at one condition, at one position, both the front and rear might be equal. Okay, so we need to keep in mind that condition also. If front is equal to rear, okay, if front is equal to rear, then we need to set the front, which means that the queue is empty here. Okay, so then we need to set the front positions, both the front and rear positions, as -1. Front is equal to rear is equal to -1. Okay, so if that is not the case, in the else part, if front is equal to, if that is not the case, we might get this situation also. If front is equal to max -1, max 1 less than the maximum element, so then we need to put the front as 0, the front as 0. Okay, so why we are doing this condition, we will understand better when I run the code and explain you by taking the front and rear positions. Hence we need to say front plus plus. Okay, so front plus plus. So that's it, we are done with the deleting part of the circular queue. So now let's say that printf /t, the deleted item is equal to %t comma data. Okay, so deleted item is equal to %t comma so data. So if you want for better understanding, so how the positions of front and rear are going to change, so let us keep that also /t. So front is equal to %t comma front. Okay, so printf /t, rear is equal to %t comma rear. The rear is equal to %t comma rear. Okay, so if everything goes well, let me call this del function, which I have already called. Okay, so let us run the program. If everything goes well without any so we have left with an error here. Probably that is of the brackets. Okay, so again we have undeclared somewhere. You've done a silly mistake of having q of friend here. Okay, cq, our name of the array. Okay, sorry. So okay, so let me add all the elements here. First let me fill up the queue, 4 and 5. Okay, so now I have all the 5 elements. If I say one more, the queue is full. So now we have a queue of elements here, so 1 to 5. So since we don't have a display function, so let's check whether our delete is working or not. So if the delete, the perfect way to check whether the delete function is working or not is to test whether we are getting the frontmost element here. Okay, so now if you say delete, the front is 1, the deleted item is 1, the front position is 1. Okay, so previously it is 0. Okay, now it's 1. Now the next, what is the element in the first position? It must be obviously 2. The deleted item would be 2. Okay, so that's what we have got here. Okay, so if you keep on deleting, so the elements at one position, so you will run out of the elements, and all the run out of the elements, and front and rear would be equal, and then we were set with both -1 here. Okay, so if you observe in our program, so this is the condition which has arisen here. Okay, so let me do the display function also, so that we would understand the program or coding with much better understanding here. Okay, so let me do the display function is very straightforward. Okay, let me put a message here, printf /n/t circular queue elements, circular queue elements. Okay, so something like that, circular queue elements. Okay, so let's say for int I is equal to 0, I less than max. Okay, so I less than max and I plus plus, so I less than max and I plus plus. So printf %t comma, so %t comma cq of I. Okay, so since we have taken the array as a global thing here, okay, so we will directly get whatever the elements stored in the array at that given point of time. Okay, so now let us run the program. If everything goes well, again we are left with 2 errors. Oh, silly mistakes, left and C here. Okay, so everything goes well. So first let us say take directly the option 3 here. Okay, so here we are getting all zeros. The reason because we have taken here let me come out of this, and once again let me say that system CLS here once again, system of CLS. Okay, so for better and more clarity, and let me say a couple of times /t also. So let me say a couple of times /t. So here, such that the elements would move a bit around, so a bit tab spaced here. Okay, so everything goes well. Let me say display. Okay, so here we are, the circular queue elements all are zeros, because that's because we have taken the array as global declaration here. So the default elements which is 0 is set all automatically, so it doesn't think that we are having the array is filled in, or we have zeros and it's full, something like that. Okay, the zeros indicate that that is the default value, so that nothing inside that. Instead of garbage values, we are having just zeros here. Okay, so first and foremost, let me take the add operation here. So now we have completed all the functions, so delete, add and display. So first let me say add. Let me keep on adding the elements. So if you observe here, the front and rear positions are now 0, because since we have the only first element added, and if you keep on taking the item 2, the rear would be incremented. Okay, so again choice 1. Okay, so item 3 and choice 1, item 4 choice 1, item 5. Okay, so I have done with all the entered all the elements inside the array. So now if I display the contents, so these are the contents, circular queue elements. Okay, so 1 2 3 4 and 5. So that's what so they are the contents of the circular queue. So now if you take the operation, so if you take the delete operation now, So let me say delete. So here the items got deleted is 1 and the front is 1. Okay, so if you take the display now, okay, so if you see, observe here, the item and the item in the front position got deleted. Okay, so item in the front position got deleted, which is 0, and the front is now 1 and the rear is now 4. Okay, so if you want more clarity about this explanation, so let me put the front and rear here also, okay, such that you would get more clear picture of what we are doing here. So let us say slash n slash t. So front is equal to, so percentage t comma front, and let us say printf slash n slash t. Rear is equal to percentage t comma rear. Okay, percentage t comma rear. Okay, so now let's run the program. So if you take the display function straight away, so if you observe here, so front and rear are by default -1 and -1. So I have taken directly the display function to check what is the current positions of front and rear here. Okay, so if I add one element, they both become 0 and 0. So now if I display, if you check the front and rear positions here, so there is one element in the queue, circular queue, and you have front and rear positions as 0 and 0. Okay, so if I add one more element, so see what happens here. Taking a choice 1 and added data item 2. So if you observe, if you take the display for more clarity, okay, so there are two elements here. The front always remains 0 and the rear gets incremented. So initially the both front and rear are 0 and 0. Excuse me. Okay, so now the rear got incremented, and since we have two elements, the front remains 0 and the rear gets incremented. Since always the law of queue or circular queue says that the element should be entered from the rear position. Okay, so you know, if I take choice 1 to add element once again, so if I take another element, data item 3, so now see, if I take the display option, if you see here, the rear again gets incremented. Okay, so if you check the position of the front, which is 0, so now if you take the delete option, the position, the element at the front position or this one gets deleted. Okay, the front is 0 and the element 1 gets deleted. If I take 2, okay, if you observe, you get the deleted item as 1 and 0 gets placed in that position. If you take the display once again, okay, so in this way this is going to work here. Okay, so now if I take, now the position of front is 1, and if you want, and there is a room in the beginning and the ending also. So in order to contradict with the normal queue, let us take that condition also. Let me keep on adding the elements. Take one option 1, let me say 4, and let me take the show the display. So here we got the 4 element here got inserted, and there is one more room in the rear part. And let me say that let me take the add option once again. Let me say data item 5, and let me take the display option. So here we are. So if it is the case of a normal queue and not the circular queue, we couldn't add another element here. Because the principle of a normal queue says that if there is a rear is equal to max minus 1, it says that queue is full. But even though we have empty room for elements in the beginning. Okay, so now if you observe, the front position is 1 here and the rear position is 4. So now we should be able to add another element here in the here. Okay, so right next to the rear is now max minus 1. Rear is equal to max minus 1. Immediately front becomes 0. Okay, so now if I take add option here, if I say 99, it gets added in the 0th position here. Okay, so now everything changes if you take the display. So if you observe here, okay, so now if you take 99 and front is equal to 1 and rear is equal to 0. Okay, so now there is no room for adding the elements here. Okay, so we are done with all the elements. So okay, so if you say, now if you try to add an element here, one, it doesn't allow us to add because, okay, so this is all about the circular queue coding. So let's walk through the code once again. So first here we have taken all the elements necessary for displaying the circular queue or building the circular queue, the first and foremost thing is an array of known as CQ and front and rear, which are very essential for developing queue based data structures. And then we have data, which is just to scan the data. So here we have straightforwardly written the code for adding an element in the circular queue, and then with all based on all the conditions we have discussed here. And also we have delete, which is very essential. Okay, so delete doesn't work here. Okay, so if I straightforwardly run the application, if I try to take the delete option here, it would not allow me to delete anything because it's a queue underflow error. Okay, so that is what the first condition here. If you understand the code better, so you need to check the output here. Okay, so if you take the output, go back to the output of the program. So first condition here, what is it is front is equal to -1. So initially always the front is -1. So that's the reason. If it is -1, the queue is empty and we cannot perform any delete operation here. Okay, if that is not the case, we need to take the element based on the front position and store it in the data, and in that position we are adding a 0. Okay, so in the same way, front is equal to if you keep on adding the elements. So if you let me show this condition in the output also. Okay, so let me go to the output here. Let me say that let me come out and run the program once again. Okay, come out and run the program once again. So if I keep on adding the elements, the first instance 3 and 4 and 5, let me say display. So now if I keep on deleting the elements, so let's say deleted item 1, 2, 3 and 4. Okay, so now the value of front and rear are both the same here. Okay, so if you take the display of elements, so if you observe here, there is only one element left in the circular queue. Okay, this is the principle of circular queue, and there is a room for all the elements here. So if I delete this element also, so our we have lost the one at last element in the circular queue also, and the queue is empty. And if the queue is empty, and therefore front and rear must be -1 and -1. So that's what we have done in this section piece of code here. Okay, so front is equal to 0. In one position, the both front and rear would be equal, and then which means that the queue is going to be empty. Okay, so that's what we have done here. If we try to perform the delete operation once again, we would get front and rear as item deleted 5, and here we got front and rear is equal to -1. Okay, so in the same way we encounter these situations also. So front is equal to max -1. Okay, front is equal to 0. Okay, so that would come when, so if I let me come out of this. Okay, and let me run the program once again. So if there are elements, if you keep on adding the elements, let me keep on adding the elements first. At first stretch 3 and 4 and 5. Let me display. So if I keep on deleting the elements, let me say let me delete the elements here 2, 3. Okay, let me display 3 and 4. Okay, so let me delete one more element here. Okay, so display. So now if I add the elements 1. Okay, let me take once again 2 and 3. Okay, so here if you check here, the front is equal to max -1. Okay, the front is equal to max -1, and front, if in that case, if you take the display function here, there is only one more room for us. Okay, so there is a room for one more element only here. Okay, so if you take rear, one more element, choice one more time. Okay, so let me say some data item as 99 or something like that. So immediately now what happens is rear became 3 and front became 4. Okay, so if I try to delete now an element, or if I go to display, and if I try to delete an element from the queue, immediately the positions are going to change here. Okay, so front became 0. Okay, so now if you take display, the front becomes 0. Okay, so because now the front is 4, which is almost equal to max -1 irrespective of the size of the rear, and now it got deleted and the 0 got placed there. Okay, so now the front position comes back to 1. Okay, so just a second. Front is 4, and now front got deleted, and the front becomes now 0. So if you want to delete an element, one more element, okay, so the front rotates to the 0th position. It can't come backwards, okay, because we have rear there. Okay, the element always must be deleted from the front end only. So that's what we have done here. Oh, I have taken for add option here, nothing happens. Okay, again the positions have changed. The front is again 0. So if I take the display, okay, the front is all again 0. So if you want to delete an element, the 0th element gets deleted. So if you take 2, the 1 gets deleted. Okay, if you take display once again, so here we get, okay, so in that way, if that is not the case, the fronts get incremented, and okay, the fronts get incremented and the elements get deleted. Okay, so this is the way to write to develop a circular queue. Hope you understood better with the understanding of the output and running the code here. Okay, so I hope you all like the tutorial. Well, give it a thumbs up and put your valuable feedback in the form of comments. Okay, so see you in the next lesson. Goodbye.